In this video, we're going to talk about antiderivative. Before we do that, let's review. Let's say you got y equals 3x squared plus 5x minus 7. What is the derivative of that? So y prime will be 6x plus 5. Now, how do you go back? Let's say 6x plus 5 is given. How are you going to go back to y? We need to use the process of taking an antiderivative. So integral of quantity 6x plus 5. This will help us to get back to the original. So basically, an antiderivative is same thing as integral. And if you have x to the n dx, where n is any real number, if you want to take the antiderivative or integral of that, that will be x to the n plus 1. You're adding 1 to the exponent, and then you have to divide that by whatever the new exponent you got. So n plus 1. And then you have to put plus c, where c represents any real number. It's a constant, because derivative of a constant is 0. And we're going back, so you got to put a constant there. And you understand it better as I do more examples. So let's say you have integral of x squared dx, or antiderivative of x squared. That's going to be the same thing as x to the 2 plus 1 is 3, and then it's divided by 3 and plus c. Now think about it. What is the derivative of x cubed over 3? That's x squared. And what's the derivative of any real number? Is 0. So this c could be any constant. What about antiderivative of 5 dx? So it's a constant, right? Now you could rewrite this as 5x to the power of 0, isn't it? Now, so how do you take the antiderivative? It's going to be 5 is a constant, so 5, and then x to the 0 plus 1 is going to be 1, and divided by 1. And then don't forget to put plus c. So it's going to be 5x plus c. Now you could check, what's the derivative of 5x plus c? It's going to be just 5. Now what about antiderivative of 3x squared dx? Well, 3 is a constant, so you could take it out. And then we got to find the antiderivative of x squared. That's going to be, well, let's put 3 right there. And then you add 1, you're going to get 3 divided by 3. And don't forget to put plus c. So 3 and 3 cancels out. You're going to get x cubed plus c. Now double check. What is the derivative of x cubed plus c? It's going to be 3x squared, and then derivative of c is 0. Now, how would you find the antiderivative of square root of x dx? Well, let's first rewrite it into this form. So you get antiderivative of x to the 1/2 dx. Now, n is 1 over 2, so you add 1, you're going to get x to the 3 over 2 divided by 3 over 2, and then plus c. And when you clean this up, you're going to get, well, x to the 3 over 2 divided by 3 over 2 is going to be the same thing as 2 over 3 x to the 3 over 2 plus c. Now what is the derivative of that? Derivative of that is going to be x to the 1/2, which is the same thing as square root of x. Now how would you find the antiderivative of quantity 6x plus 5 dx? Well, we could separate this as integral of 6x dx plus integral of 5 dx using the properties of integrals. So this is going to be 6x squared over 2 plus 5x and then plus c. So 6 divided by 2 is going to be 3x squared plus 5x plus c. Now let's double check. Let's take the derivative of this. You will get 6x plus 5 because derivative of c again is 0. Now let's do our final example here. Let's take the antiderivative of quantity 1 over 2x cubed minus 5x plus 7. So what is that? Let's separate each term. You're going to get antiderivative of 1 over 2x cubed dx minus integral of 5x dx plus the integral of 7 dx. So you end up getting 1 over 2 times x to the 4th power over 4 minus 5x squared over 2 plus 7x, and then don't forget to put plus c. So when you clean this up, you're going to get x to the 4th over 8 minus 5 over 2 x squared plus 7x plus c. So let's double check. Go ahead and find the derivative. You'll notice that you'll get 1 over 2 x cubed minus 5x plus 7. So this is correct.